unless there's people still outside. I'm assuming that the fact the room isn't full because everyone's still outside lining up for those crepes. I lined up for one. I thought they were all right. Although I suspect the lemon and sugar, I suspect what was in that bottle, it was a long time, if ever, that anything in that bottle had anything to do with anything that ever came off a tree. But anyway. Welcome to Best Practices for Orchestrator Runbook Authoring. My name is Gareth James. I'm a Senior Consultant with Microsoft Consulting Services in Australia. And I'm going to be taking you through some tips and tricks for how to write good Orchestrator runbooks. For those of you who don't like slides, you'll be happy to know I think I have a whopping total of about 4. And the rest of the time we're actually going to spend in the Runbook Designer, actually having a look at some real-world runbooks and how they're put together. So this is what we're going through this afternoon. So I'll be touching on each of these topics. So yeah, the first point really is the only thing I'll have a slide deck for. Everything else is we're gonna have a look in actually in Orchestrator for it. So let's get started on the first topic, development and change. Now, this is something that I encounter quite often, and it's one of the first mistakes that people make when they're using Orchestrator. Just so I can gauge the audience, I wouldn't mind getting a show of hands. Who hasn't ever really used Orchestrator or a Parlus, but kind of knows what it does and is looking at implementing it soon? Okay, most of you. All right, good. Because this is not super advanced. A lot of this is sort of, the tips and tricks that, I should hopefully save you some time when you first start authoring runbooks. I think there's about 2 or 3 tips in there that hopefully will save you more than the time you spent in this session. So that's my objective, is for the session to pay for itself. So the first one is to treat Orchestrator runbooks like code. I see this quite often, mainly because I think Orchestrator pretty well firmly sits in that infrastructure space. And most infrastructure people don't tend to have or have come from active application development backgrounds. So they don't have that knowledge of good application development, coding practices and those types of things. A lot of those are very relatable to the way that you want to manage your Orchestrator runbooks. I mentioned this in the previous session I gave, which was on System Center architecture. I'm a big fan of the agile software development method and applying that where it makes sense to infrastructure and to infrastructure projects. It's something that we've been doing increasingly more and more in Microsoft services, is bringing those philosophies and those methodologies to bear on infrastructure, and we're having increased amounts of success as we get better at understanding how we apply agile to infrastructure. So the first takeaway really from the session is, if you're not familiar with agile, then I would go and start reading up on it. It's a lot of the techniques are very, very useful and very good for having a controlled infrastructure. So you need dev, test, and in some cases dev, test, pre-production and production environments, sort of depending on the scale of things. Your Orchestrator runbooks do need to be treated like production code. You don't ever want to see someone cracking open a runbook in production and making modifications to it on the fly. Bad practice. So you want to treat these things as self-contained little units, like you would treat a module of code. That's how you're treating your runbook. So the first thing is to really have a check-in and check-out facility, something along the lines of Visual Studio Team Foundation Server. Now, TFS is extremely useful in being applied to infrastructure projects, not just for application development, in that it gives you the ability to check in assets. And that asset doesn't have to be a block of code. It can be an Orchestrator runbook, it can be a script, it can be a piece of documentation if you wanted to. Versioning is also very important. Make sure that when you are writing a runbook to fulfill a particular, to process an outcome, to go through a specific set of steps and process an outcome. There's absolutely no reason why runbooks can't be versioned. And going back to Agile again, a really good way of doing it is using an iterative development method. So the first version of a runbook that you author in order to facilitate a particular action, you might come up with, say, okay, I want it to do this, and then it needs to do this, and then it needs to do this. So you have a very finite set of outcomes that you want from that runbook, and you author that runbook accordingly, and that's version 1, or you might version it point 1 or whatever as you go through your dev test and pre-prod, and then version 1.0 when the first one time it hits production. And then you may want to iteratively improve it over time. So as your runbook's running in production and it's doing what it does, you might encounter some kind of corner condition where if the circumstances are just so, then the runbook doesn't work or it doesn't do what it's meant to do. Don't crack it open in production and fix it. That then is something that you should log as an improvement or an additional feature. This should go into the next version of that runbook. You author that in dev and test, bring it up through your levels, and then when it's ready, you promote that version into production. And that speaks to my last bullet point there, is changes to production runbooks, best practices, that should be made via an import. So you've tested it in dev and test, it's been validated in pre-production, you export it from pre-production, that exported runbook file is the way that you get stuff into production, importing into production. So, and of course, change control covers that. I mean, I think certainly in Australia, and I suspect it's probably not much different in New Zealand, most organisations now, these days, have a pretty good handle on process, on change control and release control, and of course promoting those runbooks into production is certainly a change that's worthy of the attention of change and release boards. The last point as well is that all runbooks should be thoroughly documented. Again, your runbooks are trying to process a particular outcome. What that outcome you expect and the stages that it goes through should be documented. It should be documented well internally within the runbook in terms of labelling of things, and it should be externally, documented as well, places like Visio and Word. In environments where they've been running this product for a while and it does more and more and more, they become more and more increasingly dependent upon it. So the last thing that you want to have happen is that something in the environment changes and a runbook breaks. That runbook, people have become really dependent on what it does, and the person who authored the runbook has left or working in another area or whatever it is, and the way that it's been put together is not sufficiently well documented, so the people coming after the fact can't really easily identify how that runbook works. So in the interim, until the runbook is repaired, it makes it difficult to try and work out where it's failing and why. And secondly is if you need to facilitate that process manually in the interim until you get it back up and running again, it needs to be documented. You need to know what you're doing. Sorry? Yep. Okay, is there a volume issue or? Oh, it's buzzing. Oh, okay. Oh, it's so crosstalk from a power cable or something. Oh, okay. Yep, sorry. Okay, so now what I'm going to do is flick over to my demo machine, and this is where we're going to spend the rest of the session. Now, I'm going to say initially apologies for the resolution, because basically we have we're obviously fairly limited in some cases as to the outputs with these sort of, if they're not high def monitors. So we are. It's difficult with a design product like this where you've got so many different windows. When you're restricted to 1024 by 768, it's not. It doesn't give you the best outcome. So we'll just have to do a little bit of scrolling around. So the first thing I'm going to cover. Firstly, everyone's seeing that okay? First thing I'm going to cover off is general structure. So how you break out your workflows. Now, I don't know if there's any technical writers in the room, but the first thing that they teach you in technical writing school is that there's a short sentence is not a bad thing. Short runbook is not a bad thing. They don't have to be 20, 30, 40 stages long. You want them modular. You want to break them up into as many modules as makes sense and have runbooks calling runbooks. You want to avoid having one gargantuan thing that does everything. You want to keep them as modular as possible. So again, it helps to think of it like code. If you have a module a particular set of steps which is going to facilitate a particular action, break it out, make it a separate runbook, and then call that runbook from within the other runbooks when you want to call it. That gives you flexibility. It makes your testing cycles a bit easier. And the other reason is you can potentially build up libraries of these runbooks. It may not be just your runbook that can make use out of it. If, for example, you've got let's say, for example, you've got a runbook that is triggered in the event of some kind of help desk ticket being raised or something along those lines. So you might have, okay, I'm getting a report that a service is not responding as expected. I want to run through a step of, like the troubleshooting validators in Windows. I want to run through the top 5 or 6 most common things that go wrong, validate them, and if they're all okay, then I'll escalate to the next level for investigation, because there's none of the basic things. Taking that into account as an example, you might say first thing you do, okay, well, let's ping the servers as a first point, making sure you're not blocking it at the firewall or whatever, but pinging the server is the first step. If that responds, I go on to the next one. Well, that pinging that server, that's a fairly common task. That could be a module that could potentially be reused by other runbooks. So just make that little runbook, that ping facility, don't hard code what you're pinging, make it a variable so that they can get called in and ping anything, and then make that a separate runbook that other runbooks could potentially utilise. So you can see here the way that it's largely broken out, and I just wanted to put a little bit of context around what you're looking at here. Microsoft Services developed an infrastructure as a service provisioning system, so for private cloud, and these are the Orchestrator runbooks that drive a lot of those outcomes. The reason why I wanted to show you this was usually when we do these types of sessions, they tend to author the runbooks on the fly, just to show you, how easy the drag and drop and all that sort of stuff is. I figure there's only so much hello world you can handle. Also, when you go back and look at these things in retrospect, because of time constraints, what they produce is so simple that when you then want to apply that to more complex situations, their usefulness runs out pretty quickly. So I wanted to show you some real-world runbooks. These are runbooks that have been tested in the field, that are part of this private cloud infrastructure as a service offering that services provide, and this has been tested on a large number of customer sites. So these are, for want of a better term, these are battle hardened, right? They've seen production implementation and have been used heavily. So one thing to notice is we've correctly labelled it here. We've got our DCS, which stands for Data Center Services, which is the offering name. We've got our DCS workflows, and underneath that you can see that we have broken out the various functions that we want into categories and then also into subcategories, which brings me on to the next point within our agenda. General structure, you want the modular, good naming practices within your runbooks. So it's almost like internal code, commenting within scripts and within code. You want your runbooks to try and, as concisely as you can, articulate what they're doing. So you can see we've got a pretty well-established naming structure through our folders here. And then the other thing that we're doing is also naming all of these actions as to what they actually do. You can see here's a really good example of that type of modular design. What this actually is within this suite of runbooks that we have for this system, there are quite a number of monitoring runbooks that will sit and wait for a particular change in a system, or will fire every minute or every 5 minutes or whatever it is. And you'll have, as you build out your runbook portfolio, you'll start to get a number of these. One of the runbooks that we have is actually a runbook which starts all the monitoring runbooks, which is a good thing. If you bring the server down for maintenance, or you need to reboot it, patch, power outage, whatever, when you bring that server back up, you want to verify that all of those monitoring runbooks that you have are actually running. So do you want to go through every time and check them all manually and make sure they're all running? Well, that sounds like an automation task that Orchestrator is really good at. So let's do it in Orchestrator. So you can see here we have our initialize, which then will go through and call all of these individual runbooks and start them. So when you write a runbook that has a monitoring task in it, the next stage should be go to my start all monitoring task runbook and add that in. So you can start them all with a single click instead of having to go through manually. Another place where naming is quite important is within these links here. Now, as you can see, we've named them very intuitively. It just says link, for those who can't, it might be a bit hard to read. Oh no, that's pretty obvious. I was expecting a laugh there, people, come on. The way that's not done by default. So if I actually have a look at the properties of the link, go up into general, there's the name there. But those won't display out of the box. So you just go into options, configure, show link labels. And you just need to check that box and then all of your links will be displayed. Where you're just going off to one path, sure, that's fine, right? Link's fine. But in other areas, and you can see here we've got one that actually probably hasn't been that well named. So let me just check out this policy and we'll correct what this should be. Sorry, I'm using a trackpad here and I despise them. Gives you an idea of, at a glance, what's going on. So we've got link to the next item, and obviously if there's some kind of error, then it'll go down that secondary path. So if I can just find one that... Okay, so here you can see there's another decision link which is more appropriately named. So here we're doing actually VM provisioning. Within this system we have Linux as a first-class citizen. We have zero-touch deployment of Linux within the system. So the runbooks, depending on what has been requested, obviously it's going to read some variables and it's going to say, right, if I'm deploying Windows, I'm going down that path. If I'm deploying Linux, I'm going to go down that path. So that's another example, obviously, where labelling is a useful thing. So the next thing I was going to cover off is link logic. And here's one of the first handy tips if you've never used Orchestrator before, that hopefully will save you a little bit of time. So let's say, all right, I'm going down Windows with this path and I'm going down Linux with this path. So if I go in here and then actually have a look at my properties and go, okay, it's a connection to Service Manager. Where's the link if I want to go down one path or another? Is it run behavior? No, it's not in there. It's not in there. It's actually in the properties of the link itself. So a lot of people complain when they first start using Orchestrator, they waste a heap of time trying to click around where to find it. I just saved you 15 minutes. So in here we can actually see why does the runbook decide to go down that path. So in this particular example, it's pulling a particular setting from the data bus, in this case provisioning type. Obviously, if that equals that value of Hyper-V Windows, then it's going to go down that particular path. So you're not restricted to one parameter. You can put multiples. So if I say add, I can then click on that and say, okay, where am I, which parameter am I going to also add to that? So I can say if it's Windows and is active or something like that. Now the next thing you'll notice here is this logic operation here is an OR. So if it's the first one, if provisioning type is Hyper-V Windows, or if it's active, it will go down that path. Now the next thing that you probably will try and do if you're a first-time Orchestrator user is try and work out how to change that operator to an AND. You can't. Don't try. There you go, I just saved you half an hour. OR is the only logic you can use. So what if I want to do an AND? How do I replicate that condition? So this is where we have include and also exclude parameters. And using a combination of include and exclude, I've not found, sometimes you have to have a good think about how you're going to do it, but I've never encountered a circumstance where I couldn't meet the logic that I needed by using a combination of include and exclude. So going back to this, if I want to create an AND operation, say, okay, I want provisioning type to be Windows and I want the is active to be yes, let's say. Let's say that's it's a Boolean, it's got a yes, no value. So we're going to say, okay, that's going to equal yes. I want both of those conditions. So if I now put an exclude operation in there and say is active is no, caps lock off, then that's going to replicate that AND, because it's going to go down that path. If the provisioning type equals Windows, yes, that condition's been met, or if that is yes, then it'll go down, but I get the AND by if it's no, then it won't go down that path. So in that particular case of a yes-no operation, it must be yes to also go down that path. So then you're replicating an AND operation there. Okay, the next thing we'll cover off, that was just some basic link logic. Now the next thing we'll cover off is use of global objects. Now these are the things that quite often get forgotten about. Quite often I'll go in and have a look at people's runbooks, and they're sparingly used if they're used at all. So within our global settings in here, we've got three things. We've got variables, we've got counters, and we've got schedules. So let's cover those off. So variables, as you can imagine, are variables, funnily enough. This is where a lot of this content as well, I'll let you know, comes from the Orchestrator team, and specifically comes from one of the guys in the Orchestrator team, he's very active, does a lot of blogging, does a lot of case study stuff, puts a lot of actual code up on Codeplex as well. So he is a great resource once you start getting into using Orchestrator and doing Orchestrator Runbook authoring. His sites will be your absolute go-to place for some absolutely golden information. A lot of this content comes from him, and also just from a bit of a mixture of my own field experience as well. I've got references to his blog and website and what have you at the back of the slide, and the slides will be available online through the TechEd page after the event, so you don't have to frantically start taking photos of the screen. You know that the decks are available. He's posted about, I think, 2.5 or 3 hours worth of YouTube videos, all on Orchestrator Runbook authoring. Most of them were done with the previous version of Parlous, but most of the principles still remain true. So that was a quick plug and reference for the information, so people don't think I'm stealing it. So we're looking at some variables here, and I mean, the use for these is pretty obvious, right? I mean, you don't want to be hard coding values into your runbooks. Any kind of file path, server names, anything that you think this runbook could be a lot more useful if that value is not hard coded and I can use it in multiple circumstances, then that's really something that you want to be using a variable for. Now, I've had some complaints, I suppose, in terms of when using a Parlous to say, well, they're actually really more like constants than variables, and whether you want to get into a runtime versus a non-runtime variable argument. But just to see, belt clip's not very good. I'll just hold it. The use of these variables is set in here. So you give it a name, you give it a description, and then a value, and that value is then obviously going to translate into the runbook. So again, these aren't necessarily runtime variables in terms of you're not going to feed in different entries potentially on the fly. There are other ways to do that. So these are more things that you set once in there and then are globally used through all the runbooks. A good example, putting it in the context of a provisioning system, is let's say you've got a multi-stage deployment system that you're going through. One of those stages is I've asked for a particular application to be deployed onto a server after that server's been deployed. One of the ways of doing that is to have all those things set up within Config Manager, within collections, and you might have an item within the runbook that says, okay, if you want application A because I'm reading this variable, then I'm going to execute the task to go and put you in the collection to get application A. When you have multiple dev, test, pre-prod environments that you're promoting these things through, you'll potentially have different config manager and the collection ID is going to change. So that's a great example of where this sort of global variable is useful. The task sequence ID in production will be different to the task sequence ID in dev. You don't want to go changing your runbooks, so you simply change it once in here and then you're away. There are a couple of special special categories of variable, and we'll go through those. So if I say new variable, one of them is, say, current time, for example. And that's how that's achieved. So then it's obviously going to pull current time and date stamp down and be used. Because I'm limited for time here, I only have an hour. I don't have time to go through absolutely everything that's covered in a lot of those YouTube videos. And Charles's video actually goes into great detail of how to use that variable and potentially how to manipulate the formatting of the time and date stamp if you need to do that, and those types of things as well. The next type of variable which is very useful are environment variables. I don't know about the rest of you guys, but certainly I find that I'm still using normal environment variables quite a lot. So let's say program files, for example, and that's simply done as the typical notation as you would see. I've already pre-created that when I was running through the test before, but yeah, just same percent variable percent. And the third type, another use for variables which is quite handy is, say, service accounts. Quite often you'll be running, you'll be executing scripts, you want to execute it as a particular authority or something like that. Variables can be used within to invoke those service accounts. So another type of variable. So that's encrypted in both the database and from the UI perspective. So if I go back and look at that. Oh God, I hate trackpads. You can see that it's not displayed there and not displayed there. So it's not. I mean, in Orchestrator, in Opalis, they were clear text values, and they were talking about, well, you can knackle them off. No, if it's not encrypted in the database, don't do it. So that's a improvement in Orchestrator. Just on improvements in Orchestrator from Opalis, has anyone actually, hands up anyone who's actually used Opalis? A couple, okay. There are a few improvements. One I'll cite is talking about the best practice of runbooks calling runbooks. How much of a pain was that in Opalis, given that the testing mechanism would only let you ever run one runbook. So if you had runbooks calling runbooks, rather difficult to test that. Installation of the web console, I think, is the best improvement. So you would actually have to, if you wanted to test it previously, you would have had to have actually executed it from the administrator console, which was a web portal. And yeah, anyone who's actually installed the web portal with Opalis knew that was an absolute ton of fun. Going through it, sort of, looking on distribution lists for obscure versions of JBoss open source components, and you just sit there going, I'm a Windows guy, I shouldn't be having to do this. Next finish, that's what I want an installation to be. That's much improved. The console installation for Orchestrator is largely a next finish affair, so that's been greatly improved. Sorry? No, I'm not a SQL guy. Okay, so next thing on my list, that was global objects. Okay, error handling. I'm going to spend a little bit more time on this one because I think it does take a little bit of extra effort, but the benefit that you derive from it will pay you back tenfold. Oh, actually, before I go into that, for the people who haven't seen much of this as well, I'll just quickly show you how those variables that I just talked about were used. So let me just find something with a script, for example. Okay, so this is a PowerShell script being executed out of for this particular task. These things in blue here are variables, information that we're calling out of the data bus. So if I want to add a variable to my script, I simply right-click and subscribe. Now I can either subscribe to publish data from the data bus, which means that anything that in that workflow that has run previously, I can pull data from any of those things, and of course each set of data will have its own, or each object will have its own set of data that you can pick from. Or I can select a variable. Now, one thing that Charles goes through when he's talking about his best practices and particularly naming conventions, and something that we're a little bit at odds on, is the naming convention for these variables. He likes to have the folder structure for the variables exactly the same as the folder structure for the runbook. So if you're writing a runbook that is going to use a variable, if the runbook that needs the variable is here, for example, then you'd see that variable under DCS workflows, server manager, connector sync, hardware profiles, for example. That's great if you're using your variables in one place. If you want to use your variables globally, then maybe that's not so much the best approach. So what I tend to recommend doing is grouping them by function. So having some kind of meaningful function name, which is particularly handy when you're authoring a runbook and you want to go and subscribe to a variable. You go, where is that variable? You don't want one massive honking list that you've got to go scrolling through. I mean, that sucks. But you do want some kind of structure to say, okay, this is the function that this variable is supplying, either server names or account names or whatever they are. Try and group them by function. Makes them a lot easier to find. Okay, so this sort of ties together a little bit. This next section is about the modularity of runbooks, about also use of data on the data bus, and also how we apply that to an error routine. So you can see up here at the top we have an error routine. Now, you can see in the vast majority of runbooks in this collection, every single action, or not every single, but vast majority of actions, all have effectively an error trap. So let's have a look at how that works. So you can see here the getRequest object. If that returns a failure, then obviously it's going to go down that path. Now, the first thing to note here and be particularly mindful of is there's different definitions of failure. This object here, the traditional, like when you first create an object, pull in another object and link them, the default action on that linkage will be, if this object succeeds, then I will go down that path. Now, that's a success of the run of the object, not necessarily that it produces a result that you consider a success. So a script is a great example. A successful execution simply means I ran the script. Script could crash. Script could not do what you want it to do. And that, from the Apollos engine point of view, is still going to be a success if you're using the default link status. You're saying, yep, I ran, it ran, that's what you asked me to do, that's a success in my book. So you can see this particular error trap is specific to if that object fails. Now, if we look at the logic on this link that's actually coming out of a script, you'll see it's different. So yes, if the actual script itself, if it doesn't run for whatever reason, that's considered a failure. But also if it does successfully run, but returns specific error code values, which means it didn't do what I wanted it to do, I'm going to consider that a failure as well. Now, this gets us into how we successfully start using objects out of the data bus to help not only have an error trap, but make that error trap meaningful. So if we actually have a look in the... Hey, delete, I don't want to do that. That'd be bad. So, and this actually says something about... I'll just diverge before I go into there. I'll just have a little speech for a second, because I like doing that. If you're going to use Orchestrator heavily, and it's usually when most organisations start using Orchestrator, they start dipping their feet in slowly, and then their use of it expands over time. Particularly in some of these new compute paradigms like private cloud, where we demand to meet the business objectives of private cloud and to have something that is economically viable, we demand very high levels of automation, which means it translates, Orchestrator is used a lot. Now, one of the skill sets that your organisation is going to need, this gets back to something that I said at the start, where typically the guys who put in Orchestrator come from an infrastructure background. They don't have, in many cases, won't have an application development background. Now, that doesn't necessarily mean that we need to start going out and looking for hardcore .NET or C# developers, but we do need to have people who know how to cut a mean PowerShell script and do it with really good app dev practices. And it's a skill set that we're starting to call the infradev. So someone with a very strong infrastructure focus, but isn't completely lost in the world of development and actually writes scripts to good coding practices. So you can see here the script that the guys have put together for this particular action. They're using a lot of error states, and they're also making use of things like trace. So basically, in PowerShell, every variable can be an array. So as you're logging actions within the script, you're just pumping that back out into what effectively becomes an output array, which is a history of what happened through the script as it ran. One of the things I've put into the references at the back end is actually some PowerShell references to how to start to write good error trapping, or devs call it exception handling, but normal people call it error trapping. Good error trapping in your scripts. And that's part of the stuff that you can look at after the session. The moral of the story is that if I scroll down to the bottom, you can see that there's a few variables here, error state, error message, and trace, that contains information about what happened within the script execution that we care about. So those variables, now if I look at the properties of that object under published data, you can see that those variables which the PowerShell script is outputting, so error state, error message, and trace, are now pulling into the published data, which are now variables, is now information on the data bus that I can consume. So if it fails, and then it goes into the error routine, what that's basically telling us is I want you to execute the error routine runbook, which is up here in my folder structure. This is the information published on the data bus that I want you to pass through to that runbook when you execute it. So it's the things like error message, object name, policy name, trace, which was the content of that variable which tells us the history of what happened within the script. So then when I go up into the error routine, have a look at the custom start property of that, these are the objects from the data bus that we are inputting from what was handed to us from the other runbook. So again, you can see error state, policy name, object name, error message, trace. This is all the information that you need to be able to determine what runbook failed, what object in the runbook failed, why it failed, and give me all the information that you were able to gather in that process that might give me a clue as to what was going wrong. All useful information, I think you'll agree. I mean, sometimes the error outputted by the errand process isn't useful. A fatal error has occurred. It's one of my favourites. Sometimes it's just a random hex value. But at least you know what runbook it was and where it failed, and most of the time you'll get some sort of a message that you can go, okay, I think I know where to start looking. So this error routine runbook does a couple of things. In the first event, it simply just writes the event log. So, and again, consuming that information from the data bus as to the failures and giving it an error importance. The next thing it does in this specific example, our system is centrally, the brain of our system is System Center Service Manager. So when one of our runbooks fails, we not only error out to the event log, but we also then raise an incident in Service Manager and supply it all of the information as to how it failed and why. Obviously, Service Manager may not be in common use here. I'm not sure how popular it is in New Zealand. Hopefully more popular than Orchestrator from the look of the attendance. But I'm hoping that, you may not always have the option to log out to a CMDB or log a ticket in a ticketing system. It doesn't have to be that sophisticated. You could be writing out to a text file. As long as you're leaving some kind of trace that people can go and look at to try and work out what went wrong. Okay, so that's sort of error handling in a nutshell. The next thing that I'll take you through, and I think this is probably more for the guys, the 3 or 4 guys down the front here that have used it before, and so that they'll get something out of this session, is a couple more advanced techniques which are quite useful, which I'll cover off. The first one is what we call routing engine. So let me just show you what that looks like firstly, and then I'll explain what it does. And also apologies for the performance. I've got a single spindle here that all my VMs are running off on my laptop, so my performance isn't huge. Remember how I said there was nothing wrong with a short runbook? Okay, this is as big and as ugly and as complex, really, as a workflow should ever get. If you're using good modular practices, you really don't want them any more complex than this if you can avoid it. So let me explain the purpose of what this does. One of the problems when you start writing runbooks, and as your runbooks get more and more complicated and do more and more steps, there's a couple of things you need to watch out for. Firstly is your testing cycles. How long does it take me to test this thing? And it's particularly important when your runbooks are executing tasks that can take a long time to run. Provisioning is a classic example. Now, provisioning is not a 10-second activity. If you're putting things into collections to do bare metal Pixie server builds, these things can run for a while. So there's a couple of things we don't want to do. We don't want to have, you do see the occasional action loop in there. Within an action, in a parlance, we can actually put a loop on that to say I want you to loop X number of times or until a particular value comes back or something like that. You want to try and avoid the use of those if you can. There are some circumstances where they're appropriate, but you want to try and avoid them. So the last thing you want to do, especially for a task that takes a long time, is to kick it off and then have a loop going, are you done yet, are you done yet, are you done yet, are you done yet? Poor use of the memory on the Apala server for a start. You also then end up having with a lot more simultaneously running runbooks than you need, which again puts more load on the server. So if you're doing a lot of provisioning, you're going to have a lot of runbooks just sitting there in that wait state going, are you done yet, are you done yet? The other thing that you don't necessarily want to do is when you're testing these things, if you've got a 20-stage process and it fails on process 12, how do you retest? Do you go back to the start, run it all again? And then what happens, if those first 11 steps successfully completed, what state does that leave the system in? Will tasks 1 to 11 work again? Or will they fail because the end state has already been achieved? That makes testing quite arduous and frankly quite painful. So what the idea of this provisioning engine is you need some kind of state management. You need a way to say, okay, this particular task that I have executed, I'm going to log it and I'm going to record where it's up to. And in this example, we're doing that through the use of Service Manager again. So as the example, when someone requests a VM to be provisioned out of the portal, that raises a change record in Service Manager. That's our state management. And that's what we use, that's what the provisioning engine leverages off. So we have a job, an orchestrator job, which goes and hits Service Manager using the inbuilt connectors, saying, give me all the active jobs. And then it looks at its status. So we use status codes. When a job is first requested in the system and approved, it gets a status 1. So you can see when we pump into our routing engine, it's all paths depending on what status it is. It's not complex. So we simply say, okay, if your status is equal to 1, then down that path you go. And that'll trigger off the first activity. What we then do is say, okay, I've triggered off process 1, whatever that is. That could be the template deployment from VMM or whatever. I'm going to now, once I've initiated that task, if the template deployment takes 10 minutes, once I've initiated that task, I'm done. Job closed, runbook closed, finished. Then 5 minutes later, same job runs again, give me all the active jobs. Oh, I forgot to mention, before we close it off, we upgraded to status 2. Close it off. Picks it up again, goes, oh, you're status 2. I know that means that the job is currently running. So I'll route you through to the runbook, which checks the status. Checks it, are you still running? Yes, you are. I'll leave the status alone. Close. Oh, you finished now? I'll upgrade you to status 3. Close. Wash, rinse, repeat. You can see where I'm going. Every time it goes into the routing engine, looks at the status, gets routed off to the appropriate runbook. The primary advantage with that, A, we've got good state management, and in fact, for the system that we have, the default reference architecture, we don't install the operator console. We don't need it. If you want to look at the status of a job, you go and look at the ticket and service manager, and it'll tell you where it's up to. We didn't install it in the first version because it was a pain in the bum, but as it turns out, in the newer version, we don't have it either, and we've left it out. That's the first advantage. The second advantage is restartability of that runbook. So from Service Manager, we can restart that job. And when we restart the job, you've got the choice of, do you want to start it again? Do you want to start it from the task that failed? Or do you want to skip over that task and progress it from the next one? And we're simply changing the status number. And the logic within the runbook, then that routing engine gives us the ability to be able to go off down any path we like. Provisioning is another example. Let's say the deployment of the Ops Manager agent fails. I don't know, because SQL had a hernia or something, or Ops Manager wasn't happy for whatever reason. Cleaner kicked the cable out, whatever. That failed, you go and look at things, but first of all, you know it failed because the error trapping worked and it raised an incident in Service Manager saying, oi, this deployment failed in the runbook that deploys the agent, and here's the error. Ooh, server not found. I go and have a look, server's down, I bring it back up. Now from there I've got a couple of choices. I can either, I'm in the Ops Manager console anyway, I might as well just deploy the agent from there. And if I do, then I can, when I restart the runbook, I can say skip that task because I've already manually completed it and keep going from where I left off. Or I could have said, no, I want the runbook to do the work. Now I know it's working again, I'll tell it, pick up from where it left off, and the runbook to deploy the agent will run again. So when I said that the session paid for itself, I'm hoping that those couple of little tips and tricks that I gave you, say will save you about an hour, which is, the length of time you're going to be sitting here. That modular runbook will save you a damn sight more than an hour in testing alone. And whilst it's a little bit more complex, it's certainly worthwhile putting in the investment because it'll pay you back tenfold. Question? No. One ticket that gets updated. Yeah, so we call back the original ticket and just update its status code. And that status code is just a free-form text field. And within our system, we have documented, we've gone with a numerical status code. You can go with whatever you like. You can say, okay, when it's code pink or code Charlie, those who work in the intelligence community can give these funny little code names to things. Numbers are easier. We've just got a list of numbers that says, yeah, if it's status 1, it means this. If it's status 1,000, it means this. You can, again, that's totally, it's just a free-form field. You can do that any way you like. Now, the last thing I'll cover off is another advanced technique which I won't actually show you, but I'll tell you about it, and then you can go back and have a look at it. And this is something that Charles has produced. Again, very, very similar, not the same, but similar to that sort of state management. Instead of using System Center Service Manager, he's using a SQL database. So what he's done, and there's a link to it in the deck, is he has produced a SQL database, or the set of scripts that you need to execute on your SQL Server to create a SQL database that will hold all of this stuff. And he's also written an Orchestrator integration pack, which again is up all on Codeplex, that you simply drag in and then utilize. So that integration pack has, I've started, I've completed successfully, I've errored, I've warninged, and there's also a restart action in there as well. So the intention being that within the runbook, when you say, I'm executing this, you then drop in from his IP, drop in the start. And that will go and write to the SQL database saying, here's a job that started. Instead of erroring out to the error routine that I showed you, you'd error out to I've either warning or failed. And that warning or failure has a restart flag within it, within the SQL database as well. So if you can mark that for a restart or not. Again, which gives you that restart logic that you can use. So that's, again, a little bit, you certainly want to be reasonably comfortable with Orchestrator before you try and start applying that particular IP or that particular stuff that Charles has written, but I've put the reference in there for you to go and check it out on Codeplex. He's got full documentation for it. He's got all the scripts you need to set up the database. He's written the IP, and he's also produced about 45 minutes worth of YouTube videos that actually show you how to use it. So it's very, very comprehensive. Again, because it's up on Codeplex, it's not an officially Microsoft-supported thing. It's something that someone in the product team has done in their spare time to try and make life a little bit easier. It's open source. There is a little element of use it at your own risk, but it's been written by one of the guys in the product team who's very conscientious about making sure that it's as complete and as well documented as it can be. I just realised before we wrap up, I was talking about global settings and completely glossed over two of the three that I was talking about. So we've covered variables. The next one is counters. Now, counters are, again, pretty self-explanatory. They count. They're very useful in terms of typically you do that kind of counting within a script. You go into some kind of loop and count the number of loops or whatever. That's great for within the script. If you want to use that in the Grader or Parlous engine, that actually becomes quite painful to do if you're doing your counting within a script, because you've got to pump it back out to the data bus, and then knowing the integrity of that value as you've got multiple things running, and it can get a bit of a headache. So what we've got is the counters. So I simply say, create a new counter. I'm going to give this one a very, very original name. Oop. And then we give it a default value, and that can be any integer. So that now exists. If I go into this, for example, I'm not going to apply it to this Runbook, but I'll just show you. Within the utilities section, this is where we have our counters. So I can go and get, all right, whoops, check it out first. Oh, actually, probably wouldn't be good to try and put it in a running Runbook, would it? Okay, that one's checked out, that's all right. So I can say get counter value. Where's my counter? So that's obviously just going to pull the value out. So then the next thing from here is you can modify the counter. So I can either increment, decrement, send it to a specific value, or reset it. And say if I want to set it to a particular value, what's that value going to be? So what are the applications for that? A good obvious one to me is a good use of Orchestrator is orchestrating repair actions if something's gone awry. So what you can do is say, okay, this particular system throws a specific error, right? But I don't necessarily want to do something every single time it does it, because it's a bit noisy and we get a lot of false positives or whatever. You can say, put a counter on it and say, okay, if this thing has errored more than X number of times, then I wanted you to go off and take a specific action. So you say, yeah, things errored, and then you can use multiple counters and say, okay, or apply logic to counters to say, if you've errored less than 5 times, do this. If it's less than 10 times, do this. If it's more than 10, go and nuke the service or whatever it is. So that's one example for applying counters within a greater Runbook context, as opposed to just doing it within scripts. The last one is the schedule, and this is again pretty powerful if it's applied in the right way. So we can just give it a name. Learn how to type. Oh, shocking. So it's pretty granular as to what times you can set. So you can say, okay, what days of the week, what occurrences, specific days of the month, specific hours, where it'll either run or not run, and then within that set, then you can have exceptions over the top to say, okay, yeah, all that except for mum's birthday, or whatever it is. So once you've then set the details of that, and we'll just say, all of that, so after hours, you can then apply that to a runbook. So let's say you've got a monitoring runbook that runs every 30 seconds or something like that, but you don't necessarily want it to be hammering the system all the time. There's specific hours that you want that thing to execute on. So then you can just say, within the actual properties of the runbook itself, I want you to apply in a schedule, and this is the schedule that you use. A good example is, I was just down in the hub earlier, I was talking to one of the Veeam guys, have a backup product for Hyper-V, and what it does is they have this sort of live VM recovery, I think they call it. I only spoke to him for a few minutes, so don't quote me. Don't go and badger the guy and said, this guy up on stage said it did this. But the idea is it takes the backups, which are then residing on the storage. If you invoke, I want to use the backup, it actually links to the version running on the storage and runs it live from the storage, with the idea that you actually defer the full restore to later on. So in his session, and he gives a demo of this, he sort of demos that, and there's an Orchestrator runbook that he has that says, oh, I've seen an alert come in from Ops Manager, something's wrong, I want to restore the backup of this VM, and he runs through that runbook. But what you could also then have is another runbook that only executes after hours, because these VMs can run from that backup live off the storage and still be providing service. And you may want to schedule the full restore to be done after business hours. So you can have a runbook that runs after business hours that says, oh, okay, go and return me all of the boxes that are actually running off this live restore snapshotty thing that they do, and say, yep, all of these, now I want you to initiate your full restore process. So that's a good example of how we can use scheduling within those runbooks. Okay, and we are just about out of time. So just so you didn't think you could completely get away from the deck. Here are the references. Again, don't feel the need to try and write them down. The decks will be available, so you can go after and check them out. The Runbook authoring best practices, so that's the complete suite of all of that IP done by Charles Joy. Again, there's hours and hours of content there, so you can say to your boss, no, I am watching YouTube for a good reason. Policy authoring, downloading exams, so these are downloadable runbooks that you can have a look to use as examples and have a look at how they've been authored. For those who are currently running Opalis and are looking to migrate to Orchestrator, migration of your runbooks, there are some got-yous. There are some legacy objects that have been discontinued. There are some behaviours that were permitted in runbooks that are no longer permitted. So you want to have a look at that link to look at what you're in for migration of your policies into runbooks if you're going from Opalis to Orchestrator. The Coplex, that's the external logging tool that I was telling you about before, that Charles Joy has written, that IP and database and everything for that state management of your runbooks, that's there, and then just an example of error trapping in PowerShell as a final link there. And we're bang on, so I'll just be down the bottom if anyone has any questions, but thank you very much for your time.